Here we are at example 1 from our 2.5 set of notes. But before we dive into this guy, let's go ahead and look at our definition for direct variation, so that'll help us out. The variables x and y vary directly if you have some constant. I'm actually going to go ahead and switch this variable. Instead of an a, we're going to make him a k. So then you end up with y is equal to some k, constant of variation k, times x. In other words, when you want to find out what k is, you simply just have y divided by x, and then you can look and see that k is equal to that. Now, the reason why we actually care about direct variation is we don't always necessarily have a y-intercept, and so our slope is always going to be that k, that constant of variation, and our y-intercept will actually always pass through the origin. And there are various scenarios, and we're actually going to see some of those in these set of notes, that actually apply when you're just looking at direct variation. Now, it's also important to note that this k value is a non-zero constant. In other words, k cannot be equal to 0. Alright? Now, again, just reiterating, direct variation will always have a y-intercept passing through the origin. So it's important to note that you will never ever end up with a y-intercept if it is in fact true direct variation. Now, looking at example 1, we see that we have, suppose y varies directly with x. So in other words, y, just in that statement, y is equal to some k times x. Well, we're given a y and we're given an x that satisfy this equation. Let's go ahead then and throw those values in there. We end up then with 48 is equal to some k value that we don't quite yet know. But we know the x value is negative 12. And from this, we can actually go ahead and find k. We do this by dividing both sides by negative 12. And so we see that k is then equal to 48 divided by negative 12 comes out to be negative 4. So that's great. We found out our k value. But now we have to go ahead and write the equation that relates x and y. So for whatever y value that we're looking for, we at least know that our constant of variation is always going to be negative 4 times whatever x value that we decide to throw in there. Now for part B, it's saying find out what y is if you know that x is 5/8. So we end up then with, we don't know yet what y is, that's what we're trying to find, is equal to our constant of variation, negative 4, times the x value that we were given, 5/8. Well, it looks like our y value just comes out to be negative 4 times 5 is negative 20 over 8. And just simplifying things, we end up with y is equal to, dividing the top and bottom both by 4, we end up with negative 5/2. So as a result, that would have to be our y value. Notice too that this using direct variation, this actually creates a point, 5/8, comma, negative 5/2. Likewise, sometimes we're actually looking to determine what is our x value if we are given our y. So let's go ahead and using the same exact equation, y equals negative 4x. Well, we know what y is. It's negative 3 is equal to negative 4 times x. We have no idea what x is. That's what we're actually trying to locate. But we can very easily find them just by dividing negative 4 on both sides. So then it appears that x is equal to negative 3 divided by negative 4. Negative divided by negative simply comes out to be a positive 3/4. And again, from this, you can actually then construct a point if you really wanted to. So 3/4, comma, negative 3. So essentially, at least graphically what's going on, is k is pretty much just like your slope is, only we don't have a y-intercept. So if, again, it has to go through the origin, so if you were to throw in 0 here for x, well, negative 4 times 0 is 0 for a y, so it does pass through the origin. And now let's go ahead and just throw some points in there. Well, we said that at 5/8 up with negative 5/2. So we'll just say he is about here, just at least for the graph. Then at 3/4, we ended up with -3. So a little bit more, closer to 1, we ended up with -3. Notice, though, that these points do line up. All right. So again, though, that is example 1 and our definition for direct variation.